I'm going to find the equation of this circle here. To do this, I draw any radius on the circle, so I've drawn this one. I'm going to call the point where the radius meets the circle x, y. Now I know that if I drop a line straight down here, that distance will be y, and if I draw a straight line across here, that distance will be x. Now I've created a right-angled triangle, so I can use Pythagoras' theorem to find the equation of the circle. I know that this radius is 5. So Pythagoras' theorem tells me that x squared plus y squared equals the hypotenuse squared, which is 5 squared. So I get x squared plus y squared equals 25. This equation will be true for whichever point I choose on the radius of the circle, because the point will always be xy and the radius of the circle will always be 5. Therefore, this is the equation of the circle, with centre the origin and radius 5. I'm now going to take this one step further and find the equation of any circle with centre the origin. I don't know how big this radius actually is, so I'm going to call it r. The point here on the circumference of the circle is xy. So this distance here is y, this distance here is x, and we've created a right-angled triangle. Using Pythagoras' theorem, we get that x squared plus y squared must equal r squared. And this is the general equation of any circle as long as the centre is the origin. We can now use this general equation to help us answer some exam-style questions. I'm asked that if a circle has its centre at the origin and a radius of 4, what is its equation? Well, I'm going to use this. It's x squared plus y squared equals the radius squared, so that's 4 squared. So I have x squared plus y squared equals 16, and this is the equation of that circle. In this second part, I'm given the equation and asked for the length of the radius. So remember, it's x squared plus y squared equals r squared, and we've got 49, so r squared is 49. That tells me that the radius must be the square root of 49, which is 7. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. You'll need some graph paper for this one, and you'll need to draw this set of axes. When you come to answer part B, I hope you realise that what you're actually looking for is the places where the line intersects the curve. Press pause and have a go. When you're ready, press play. This should be your answer for part A. From this equation here, you know that the radius squared is 9, so the radius of the circle must be 3. For part B, you should have started by drawing the line x plus y equals 1. That's this line here. You might have used a table to help you get some values. It doesn't have to look exactly like this is just an example. You then need to find the coordinates of the points where the line intersects with the circle. So that's here and here. So if I look at this one, I have an x value of minus 1.6 and an associated y value of 2.6. And if I look at this one, I have an x value of 2.6 and an associated y value of minus 1.6. So these are the solutions.